In this video, I'm going to attempt to explain to you the main principles of the flood hydrograph or the hydrograph. So I'm going to talk you through some of the main points of the hydrograph, some of the things that you'll need to remember. So the hydrograph shows us, a hydrograph means the amount of water in the river at any one time that's captured, flowing through, something that measures it at any point in the river. The flood hydrograph shows us what happens when we've got excess rainfall and the river is maybe likely to flood. So what we've got on our axes, first of all, is on the left-hand side, we've got the amount of centimetres of water in the river, and this is the river discharge, the amount of water flowing through the river. And I've put Q to represent discharge because you sometimes see this in some of the things that you'll revise or in some of the books, etc. So I'll put that on here. And this is measured in cubic metres per second, or QMEX. So you'll see that on the side of the axis as well. Along the bottom, we've got time. This is from when it first starts to rain, to when it stops raining, when we've got lots of water in the river, to when the river goes back to its base flow, which is its normal flow. And that's this blue line here, that's base flow, which means the level that the river is normally at when it's not raining so much, and the amount of water that flows through in discharge at this time. So what we can see here is on the left-hand side, we always have the rainfall. And this rainfall is just a normal rainfall graph like you might see, with mostly blue blocks showing the rainfall, and it will go from when the rain starts over time to the peak rainfall, which I haven't labelled, but it's here, and then when the rainfall falls off again. And this can be over maybe 12 hours or 24 hours. It just depends on how much water we've had, how much rain we've had, etc. If we've got very, very heavy rainfall, then over time that water is going to end up coming through the basin, the river basin, through the ground, infiltrating or maybe not infiltrating, whether the ground's permeable or impermeable, but getting into the river channel. And that river channel, depending on how much water is in it, depends whether that river is able to take that water out to sea or whether it will actually overflow and the river will flood. So what we've got here then is we've got this black line which represents the flow of the water or the discharge of the river over time when we've got a flood, when we've got a heavy rainfall and possibly a flood event. So what we've got here is the when it starts raining, that water will take some time to get into the river channel because it will have to come through either trees and be intercepted by trees, come through the ground, infiltrate into the ground, percolate, come through as groundwater flow, etc. Or if it's a built-up area, then it will hit concrete or tarmac, it will get into drains and it will get into the river. So first of all, this black line here, as you can see, doesn't show much difference in the amount of water that's in the river, the discharge, because it will take some time for that rain to kind of get into the river and get through the system. So over time, as you can see, we've got this part of the graph which is called the rising limb, and that's often quite steep. And that starts happening when the water's getting into the channel and it's been through whatever process it's been through, either through an urban environment or a more rural environment with more vegetation, etc. So we've got up at the top then, the graph goes up to here and then it starts to fall again, but right at the top, this is peak discharge, or the peak amount of water that's in that river. And this is very, very high. This is now very high in terms of cubic metres per second that's running through the river. And it's a big, big possibility that this river is going to flood because it's reached its full capacity and it can no longer take the amount of water that's been put into it without overflowing because the channel's just not deep enough and the water's just not moving fast enough. So this is called peak discharge. I'm going to carry on with this black line for now, and I'm going to say that what happens next is that as the rain starts to ease off, as you can see here, we've got rainfall being quite low, getting higher, reaching peak rainfall, and then dropping again, the rainfall dropping again, then obviously the discharge will drop as well. So this falling line tends to be a little bit more shallow than, because the water, it just does, because the water's kind of getting into the river in bits and pieces now, and the rainfall's stopping and isn't as intense. So the other thing that we need to remember here is this thing here between peak rainfall and peak discharge in the river. So this is the time when it's at the time when it's rained at its maximum and then the rain eases off. So this could be a 10-hour period or a 12-hour period, and then the rain ceases or starts to decrease. And from that time, that's the peak rainfall. For this peak rainfall to get into the river, the time it takes this water from when it hits the land at most intense to going through the ground or not through the ground, like I said before, depends on whether it's permeable or impermeable, then the time it takes from this peak rainfall to when it gets into the river and we've got peak discharge, this is called the lag time. And the lag time can be quite short, and we can have quite a small period from when we have peak rainfall to peak discharge. And this would be when we have got urban surfaces, so we have got drains taking the water very, very quickly into the river, and we've got impermeable surfaces, so we've got concrete and tarmac and roads and pavements, etc. So there's no infiltration, and that water will go very, very quickly into the river. So the lag time is very, very short. And when we have a very short lag time, we've got a really big possibility that this river is going to flood, because there's just no way that that river can take all of that water at such a high amount and get it and move it out to sea. So we very often, if we've got a very short lag time, we'll see the river get to bank full very quickly, burst its banks and cause a lot of issues and a lot of flooding. If this lag time is nice and big, so if we've got an area that is vegetated, that has trees, that has vegetation, where the water is intercepted and then infiltration happens, percolation happens, through flow happens, etc. This will slow down the amount of time it takes the water to get from the land into the river. The lag time's now nice and long, nice and big lag time in terms of time, obviously. And so this river is less likely to flood and therefore less likely to cause any issues. The base flow, as I said before, is the ordinary amount of water that's in the river just from it raining just generally. But this is a storm or a flood hydrograph or storm hydrograph, and this shows what happens when we have very, very high rainfall. So lots of key terms to remember here, and you can put into this as well when you're talking about the flood hydrograph. You can talk about lag time in a lot more detail, and there's often more questions that might come up with this about what happens when lag time is very, very long and what happens when lag time is short and the reasons why. So again, you can talk about lag time being long, having lots and lots of time, talk about rural areas and vegetated areas, or you can talk about when lag time's quite short, when you've got more urban surfaces where the water can't infiltrate. So there are lots and lots of key terms to go with this, but it might be a good idea to list those key terms and define them. You can see that in another video. You can see all the definitions of those things with another picture. But for this instance, we can tie those key terms to the flood hydrograph, because obviously the two things tie together.